Okay, so let me see if I can find it on. Okay, it's not live. Let me. I wish we could get rid of that borderline, but
Yeah.
we will get rid if we
Should we break it more?
what will we get for it? Okay.
Edit.
Are you doing what do you call it? Uh-huh. Is this better forward or back? Yeah, I can see, right? You can see, right?
Yeah.
Shape and space. So deepen the chalk and write in bold, like bold as well. Okay, I want to go and check what's down. Can I use someone's laptop? Can I use your laptop so that I can be responding?
Okay.
Thanks, miss.
I can remember. Oh no, but you are using it. You are using it. Apita then said,
I'm going to say it now. You know, it just came so here. Oh, three.
is it the same link? Is it working with the same link or?
Do I have to change the link?
Yeah, check for me.
Okay. Let me share the link. Actually,
Yeah.
so the flag is better.
Okay. And then ready. Is it showing?
You are the page. Then you can send it to me.
Okay, let me show you. I only sent it to you.
It's on the page. Oh.
No, I checked.
Oh, okay. Okay. Okay, so welcome to today's episode of the math class. And today we are taking the topic shape and space. Shape and space. So, talking about shapes and spaces, people really don't get why they should be doing things like this in junior high school or even applying it anywhere. But one thing you haven't noticed is that even the room that you are in, there are a whole lot of application of shape and space. For example, the window you see, the door you pass through before getting to your room, the chairs in your room, and everything is an example of the application of the shape and space that we are talking about. So if you contract somebody to build a house for you, the person is going to consider what you are going to use the room for and then make some shapes that will fit the purpose for which you are going to use the thing for. So all these things come together to tell you that there is a need to understand shape and then space. The two key words here, shape and then space. When we talk about the shape, we are talking about how the thing looks like. I have this box here. This box is made up of a certain shape. For each side that I turn, you can see a shape. This side, the shape here is different from the shape here, and everything. Then when we talk of the space, we are talking about the volume of the thing or the amount of thing that can be contained in that shape that we are talking about. So usually if I open this thing, you can see a hole in there, and then we are talking about the space there. If I place this thing on the table, it occupies some amount of space in air. So that is what this whole lesson is about. So we are going to consider that. In junior high school, when you are talking about shape and space, there are two main things that you should consider. The first thing you are going to consider is what you call plane figures. And then the other thing you are going to consider is solid figures. Okay, so one may ask, what is the difference between these two, a plane figure and a solid figure? When we talk about a plane figure, we are talking about any shape at all that you can see in 2 dimensions. Any shape, anything at all that you can see in 2 dimensions. By 2 dimension, I mean that I can draw it plainly on the board without struggle, like this. All these guys are two plane figures. They are plane figures because they are 2 dimensional. They are 2 dimensional because there is no thickness in addition to their shape. So I want to give an example using a book. So if I have a notebook, let's say I pick this sheet out of my notebook. This is a plane figure. It's a plane figure because when I look at it this way, it's just a tiny fill of paper. There is no thickness aligned to it. However, when I pack more of these sheets and then I make a book out of it, something like this. Now, this is a solid figure. It's a solid figure because we still have the plain sheet I showed, which is this one. But in addition to it, I have a certain depth this way too. So this makes this book a 3D figure, which then becomes a solid figure, whilst the individual sheets in them are plain. In this topic, we are going to consider some words as are used in the junior high school level and examiners do ask questions about. I strongly believe that if you understand some of these things, then you appreciate the mathematics you are doing in a better way. I usually tell people that mathematics is not always about calculations. So on this topic, we are going to do just some knowledge that you are supposed to know about them and not the calculations that go with them. The calculation will have to do with the areas and the volumes of these plane and solid figures, which will be done on another day. So we are going to look at lines of symmetry. We are going to look at diagonals. We are going to look at vertices, edges, faces, and many other things. So let's begin with this one. So my objective for today is that by the time I am done with this lesson, you should at least know the meaning of all these things and how they apply in shape and space. And then we go into the BECE past questions, look at some questions that involve these simple mathematics concepts, and then we answer them. Okay. So when we talk about plane figures, like I have already mentioned, plane figures are two-dimensional shapes. And generally, we call them by name based on the number of sides that come together to form that shape. So generally, these two-dimensional figures can also be called as polygons. So with these polygons, they get their name out of the number of sides that make up the polygon. And the smallest we can get is, so here I'm putting the number of sides against its name. Okay. So the smallest you can find has 3 sides, and we call it a triangle. I am sure you are surprised why I'm bringing in this, because maybe you know that when we talk about polygons, then we have to start from pentagon, hexagon, and all those things. But actually, a triangle is also a polygon. So a polygon is a closed-sided plane figure. And then, like I said, the smallest you can get is this one with 3 sides, which we call the triangle. Only that with a triangle, we have different types of triangles. We have the scalene, the isosceles, and then the equilateral triangles. The next one is a polygon with 4 sides, and we call it a quadrilateral. Okay, so here too, the quadrilateral has so many others by name, specifically based on how it is constructed or how the specific shape look like. But any plane figure you see with 4 sides is generally called a quadrilateral. With that one too, we can get examples like the square, the rectangle, the kite, and many others. The next one we have is with 5, and it is called the pentagon. So the penta there means 5, so yes, pentagon. The next is with 6, which is called the hexagon. The next one has 7 sides, and it is called the heptagon, or you can also call it the septagon. For 8, call it the octagon. For 9, we have the nonagon. And then I would like to end this at 10, which is the decagon. But you can find out others and how they are called. Okay. Now I would like to take the lines of symmetry. Okay. So usually lines of symmetry are connected with these shapes. And basically what it means is that what is the line that you can draw through that shape such that it divides it into two equal parts, such that one can lie on top of the other exactly. It fits exactly on top of the other. So let's say once again I have a plain sheet like this as my plain figure. The question is, how many ways can I fold this sheet into two such that one will lie on top of the other exactly? How many ways can I do this? Okay. You may be tempted to try putting it across this way. So you start from this corner and then you end it up here. Okay. Let's see what happens. You see, yes, now I've divided this sheet into two. However, this portion is not lying exactly on this portion. So then I can't consider this line which is passing through this corner to this corner as a line of symmetry. Okay. Now let's try folding it this way. Okay, now you can see that I have folded this thing into two. This lie exactly on top of this one. So then, with this shape that we all know is a rectangle, at least I have seen one line of symmetry, which moves from the top here to the down here. Okay. Another way I can fold this paper so that it lies exactly on top of the other is when I fold it this way. Okay, so like this. So then it means that when we take the rectangle, it has two lines of symmetry. So anytime you are asked any question about a line of symmetry, just imagine yourself folding that plane figure which is given to you into two equal parts such that one lies exactly on top of the other. And then you count how many times you can do that using that plane figure. So by examples, let's say I have the rectangle and we just note that it has two. When I take the square, so the square is like a rectangle, only that it has all sides equal. So because it has all the sides equal, let's say, let me try and see if I can get a rectangle out of this one. Okay, so let's say I have a square here. So now with a square, let's try this way. Okay. So now, unlike the first case, now this side is lying on top of this one. So that is one. Taking the diagonal this way. Then it means that if I go this other way too, I will get exactly that being done. Okay, so this one too is here. So we had 1, 2. Now we can go this way too, which now gives us 1, 2, and 3, and then finally I can fold it this way too. So now it means that for a square, we are going to get 4. For the triangles, if you have an equilateral triangle, we have all sides being equal, so you can fold each one on top of the other, and you should get that. When you take the isosceles, triangle that has 2 sides equal, so it means that the line of symmetry there is just 1. And then when you take the scalene, which has no sides being equal to another side, it means there is no way you can get that. Now, when you take a circle, imagine how many ways can you put one on top of the other such that they lie exactly on top of the other. So we can try guessing for the circle. Okay. Now, the difference between the line of symmetry and then the diagonal is that the line of symmetry divides that figure into 2 equal parts such that one can lie on top of the other exactly. However, when we take the diagonal only is a line that moves from one corner to the other corner of the. So let's say I have a rectangle this way. So I am moving from here to here. So this line here is what I call the diagonal. But this line and these other lines are lines of symmetry. When we take the square, you can see that 8 lines of symmetry, 2 of them are also the diagonals, because this divides this one on top of that. And then when I take this other one too, it does the same. Though they are diagonals, they also serve as lines of symmetry. And then when I have this one and that, then it gives us the 4. Okay. So still on plane figures, we are looking at the next thing, which has to do with vertices and edges of plane figures. Okay, so let's take a simple example like the rectangle. The rectangle looks like this. Now you are saying that the corners for which you have the lines joining is what we call the vertices. The singular form is just vertex. So one is a vertex, but when you put all 4 together, then we have vertices. Now we are saying that that line that joins one vertex to the other vertex is what we call edge. It's what we call the edge. So that is it for plane figures. So in the same way, if you have a square, you are going to get vertices here, here, and here, and still be joined by edges. Now, another question to ponder about is, if I have a circle, how many vertices are there and how many edges do you think we will get? So you ponder about it, whilst you still ponder about how many lines of symmetries we have for the circle. Okay. I will now want to shift attention to the solid figures, because that's where most of our case will be today. Solid figures. So when we talk about solid figures, I simply would like you to consider a solid figure as something which can hold something in it, something we have some space in it that we can put something in, or maybe something that is filled in itself. So this is an example of a solid figure. It is solid because I can put something in this thing, or even if I assume it is already filled, then it can occupy some space. So this is a solid figure. Okay. So there are some words associated with the solid figure, and then that's what you are going to look at. But before that, let's give some examples of solid figures. So some examples of solid figures. One is a keyboard, which you already know. So something like this, which looks like a rectangle, but in 3 dimensions. So it means that when we take a rectangle only have a length and a breadth. But when we project it into the 3 dimension, then it gets an additional dimension, which we call the height. So let's assume this is my rectangle. So this rectangle is here, but I include a certain depth to it. So let's say from here up to here, then now I have a 3 dimension. If I take it from this side, I can say that this is my base shape, and you can see it's a square. So if I project this square, put one on top of the other, on and on and on until I get to this height, then this becomes a solid figure. So this is the length, the breadth, and then this becomes the height of it. Okay. So this should look something like okay. And you can look at the cube. So the cube is also just like the keyboard, only that this time all the sides are equal. And one example that you usually see is the Ludo die, or maybe the Chocomelo that you take every day. So that's an example. Another thing that you can talk of is the sphere. So wrong placement. So the sphere is something like the football. Or the orange, or anything like that. Okay. The next thing we can consider is a cone. And a cone has a cylindrical base, and then it's as if there is a triangle around it. So it is drawn this way with a cylindrical base. Okay. Another thing we can think of is what you call the cylinder. So the cylinder also has a circular base, but on top too we have another circle. So you have a circle here, and then it is joined to yet another circle, like that. Okay. Now, I would like to talk about one thing that usually confuses students when it comes to these solid figures, and it has to do with the difference between a pyramid and a prism. Okay, so I know you have been encountering these two words and sometimes you get confused what the difference between the two are. So when you take a pyramid, we are saying that a pyramid has just one base figure. So we have one base figure. But when it comes to the prism has the same base figure shown also on top of it. So let's say this is duplicated base figure. The second thing is that the sides around the pyramid is always a triangle. So we have triangular sides, and then when it comes to the prism, that is supposed to be rectangular. So when I take this shape, the duplicated shape that I'm talking about for the prism, because this is a prism, is this one. And this shape is the square. And I can see the same thing repeated here. And the surrounding figure, this is a rectangle, this is a rectangle, this a rectangle, and that is a rectangle. So like this. So let's say the name. So when you are naming it, you mention the base figure plus pyramid. And then here, when you want to name it, you still mention the base figure and then you add a prism. Okay. So let's say I have, these things are always difficult to draw. So I will do my best to get it done. Okay. So when you look at this figure drawn here, we can see the base shape here as, let's say, this is a square or a rectangle. So if you see it as a rectangle, then this figure is going to be called a rectangular pyramid. And it is a pyramid because when you look at the sides here, you can only see rectangles, triangles. So we have a triangle here. When I take that other side, there is also a triangle here. When I take the one facing me, deep down there is also yet another triangle. So we have 4 triangles coming together, and you have the base to be this rectangle. The same way, if I have this same rectangle, So this becomes, the base shape is a rectangle. So this becomes a rectangular prism. But this rectangular prism has its generally accepted name, and that is what you call the keyboard. So this is the same as that. There is yet another pyramid that has the base to be a triangle. So we have a triangle as a base, and then its surrounding figures are also triangles. I will try to see whether I can draw. So let's say we have something like this. Okay, so we have something like this. So you can see that the base is a triangle, and then the surrounding ones are also triangles. And this we will call a triangular pyramid. So what we use to check whether it's a prism or a pyramid is what is around the base. What is around the base. This triangular pyramid is also popularly known as the tetrahedron. The tetrahedron. So when you hear a tetrahedron, it's the same as the triangular pyramid. So you should take note of that, because sometimes your BC question will ask you to identify something, and maybe you will not see this triangular pyramid, but you see a tetrahedron, and then you should always know that they are the same. So that is it. The last thing I want to talk about before we go into the past questions that you have seen so far in pyramid is what you call the net. Okay, so when we talk about the net of a solid figure, what we basically want to say is that assuming I want to dismantle this figure into a plane figure, that is, assuming I want to construct this keyword from, let's say, a plane sheet, what is the shape that I should cut in the plane sheet so that when I fold them together, I will get this thing back? So now, how do we do it? So let's see. Now, this also brings the idea of faces and then edges and vertices. We know that with the plane figures, we said the corners where they are connected is called the vertices. And then the lines that join them are called the edges. So in solid figures, there is an additional thing that comes out, and that is what you call the face. So the face is where these edges are meeting to form another plane figure. So when I take this vertex, it is connected by this edge to this other vertex. So this one, there's another vertex, and this another vertex, and then there. So we can see that these four edges with these four vertices form a certain plane figure here. So that plane figure that we see is what we call the face. So we can say that when two faces meet, they form an edge. And then the point where all the edges are meeting is what we call the vertices. So when we talk about the net of the figure, what you are going to do is to draw the faces of these figures by bringing all of them known. So now we are going to see how many faces this one is going to get us so that we can get a net out of it. So let's say this is what is being represented on the board. Now we are counting. We are saying that where we have another plane figure is what we call the face. So here, if I am counting and I have 1, 2, 3, 4, I have 5 here and then 6. So this tells me that I have 6 faces for the cuboid. So I can draw it as, let's say, 1, 2, 3, 4, 5, and 6. So if I open up this thing, this is what I'm going to get. 1, 2, 3, 4, 5, 6 faces. 6 faces. So this is the net of a cuboid. When I take the square, the cube also has 6 faces. So the net will also look similar to what we have for the cuboid. Only that this time around, you know that all the sides are going to be equal. I can decide to put the 5th here and then even put the 6th one here. It doesn't matter. All that matters is that at the end of the day, I have 1, 2, 3, 4, 5, and 6 faces. Okay. I will leave the sphere for you to give me the net, and then for the cone, we are going to get something like this. And then for the cylinder, you are going to get something like okay. Now the tetrahedron. We said that the tetrahedron has a triangle as its base. So if it has a triangle as its base, then we are going to get that base triangle as this one. And then each of these triangles are also surrounded by another triangle. So we have triangle here, another triangle here, and then finally another triangle here. So 1, 2, 3, 4 triangles like that. The net for the rectangular pyramid. So we have our rectangle at the base, and because we are saying it is a pyramid, we know that the surrounding figures are going to be triangles. So this becomes triangle, there becomes a triangle, here will be a triangle, and then this also becomes a triangle. So that will be it. Okay. You can see that when we open up this cylinder, this side is a rectangle. So it means that the cylinder can also be called a circular prism, because its surrounding is a rectangle. And then we said that if you check around it and it is a rectangle, then it is a prism. If you check around it and it is a triangle, then it's a pyramid. So this becomes a prism. Then should this one be a prism or a pyramid? You look for more on that. Okay. So like I said, this is what you need. So I've mentioned the two-dimension, three-dimension figures, and I said the two-dimensional figures are the plane figures, the three-dimensional figures are the solid figures. Then I mentioned the lines of symmetry. We are saying lines of symmetry divide the plane figure or the figure into two equal parts, such that one lies on top of the other exactly. Then the diagonal is one which moves from one opposite vertex into the other one. Another thing that we talked about is the faces, the edges, and then the vertices. So we are saying that the points that we use to connect is the vertices, and then we are going to have where the lines that connect them being the edges, and then we have the faces, which are the plane figures that make them up. So I have about 5, 6 questions here from the BEC, and then we are going to go through them quickly. They are very straightforward. Okay, so the first one we are going to take is from 2003, and then we are looking at question 29. Question 29 of 2003. So this is how the question was put. So it says, which of the following represents the net of a pyramid? Which of the following represents the net of a pyramid? And the possible answers they gave were so this is option A, option B, option C, and then option D. Okay. So we have option A, option B, option C, and option D. And then the question is, which of these diagrams represents the net of a pyramid? So you can leave your answer in the comment box even before I show which one. So here, the idea is that you look out for the concepts that you have learned so far. Like I said in the beginning, not all mathematics questions will involve calculations. So some of these things, you should be expecting them. So looking at this, which one represents a pyramid? So we can see that the first idea you should come up with is looking out for the base figure and then checking the surrounding shape. So when you look at this one, there is a base figure which is rectangle, and then what is surrounding it is also another rectangle. When you look at this one, it's also the same. When you look at these two, the surrounding ones are triangles, but this one has 3 with a 3 inside, a 3-sided figure inside. This one is a 4-sided figure with 2 triangles around it. this cannot even give us a solid figure because it will be a half something. But this we can see resemble what we had here, which is the tetrahedron. So this will be your best option to take for. Okay. The next is from 2007, and then we have question number 3. And then the question says that name the figure above, and this was the figure. So name the figure above. The figure is here, and I know you know the name, so you put the answer there. The next one is 2008. 2008, question number 9. So question number 9 in 2008, also a very simple question. And then the question says that which solid figure can be made from the net above? So which solid figure can be made from this net? So that one, so you can go ahead and put your answer there. Which solid figure can be made from this net? The next is from 2010. No, let's go 2009. And 2009 question 3 says that how many faces has a cuboid? How many faces has a cuboid? Then 2010, question number 27. Question number 27 is also saying that how many lines of symmetry? How many lines of symmetry has a triangle? How many lines of symmetry has a rectangle? Sorry, not triangle, rectangle. So that one, so you go ahead and you put your answer there. And then we go to 2011. 2011, question number 11 also has this same figure and is asking you to tell the figure that you can make out of it. And then when you go to 2013, the question that came also asks how many diagonals can you get from a rectangle? How many diagonals? In 2010, it was how many lines of symmetry, but in 2013, they are asking you how many diagonals can you get? And then question 30 of 2014. Question 30 of 2014. That one too is asking how many faces has a cube? How many faces has a cube? How many faces has a cube? 2015 had 2 questions on shape and space, with the first one on 25, question 25. That one asks how many vertices has a cuboid? How many vertices has a cuboid? That is question number 25 of 2015. And finally, 2015, question number 34. Question number 34. Okay, so that one too says you should name the figure drawn here. So what do you think is the name of this figure? based on whatever you have learned today about prisms and pyramids, what are you going to say is the name for this figure? And that brings us to the end of today's lesson with me, Joe. Catch you next Sunday.